In Essential Task 8.5c, we are briefly going to talk about the spinal cord, which will wrap up our look at the central nervous system. We've previously talked about the brain in the last two essential tasks, and I sort of left off to the side the spinal cord, which is the other element of the central nervous system. Today, we're just going to talk about this one box isolated over here on the right. So it is, in fact, a one-box concept map today. You can hold it horizontal, vertical, honestly, however it is that you choose works perfectly fine. I will allow you to pause the video here before proceeding into this one-box concept map. The spinal cord is a series of interneurons that connect the brain to the rest of the body. To be more specific, and we've kind of referenced this process several times throughout the unit, when somebody touches your fingertips, or you in fact touch your fingertips when you, for example, pick up a pen, I don't quite have that Sharpie anymore, you are activating sensory neurons in your fingertips. Those sensory neurons are sending messages through neural impulses called action potentials, activating those neurons from resting to action potential, and that message is being sent to the spinal cord. The spinal cord then has the responsibility of taking the message that was received by the sensory receptors on your fingertips and sending it up to the brain for processing. That information will be ultimately processed in the somatosensory cortex of the parietal lobe, to be specific, pertaining to the sensory input that you received at your fingertips. In addition to that, if you decided, after experiencing sensory input on your fingertips, that you actually wanted to let go of the pen like I just did, the motor cortex in the frontal lobe, via motor neurons, just triggered messages to my muscles in my arm to actually drop the pen. That message went from the frontal lobe, and specifically the motor cortex, through the spinal cord, and the spinal cord then facilitated the activation of the motor neurons in my arm to, again, drop the pen. So the spinal cord plays this intermediary role. It takes incoming sensory input from sensory neurons and sends it up to the brain for processing. It also can send down motor messages out to the corresponding muscles to trigger motor neurons to actually produce some of the movements that we've been discussing throughout the unit. In addition to playing the middleman between motor and sensory neurons in relation to messages to and from the brain, the spinal cord can also produce what's called a spinal reflex. I referenced this earlier, but for example, if you were to touch something that is scalding hot, so pretend my phone was a hot plate, one that maybe you even put into the oven. You cooked something on a plate in the oven. The moment you touch that scalding hot plate, your arm is going to retract back. What happens is the sensory information about what it is that you are touching, so following this, pretend this is the hot plate, that sensory information, that really strong sensory information is sent from sensory neurons through your arm to the spinal cord. In the spinal cord, the interneurons, indicated here, acknowledge that the sensation that is being felt is excruciating pain. And instead of sending that message up to the brain in order for the brain to process what it is that you are experiencing, the interneurons can actually produce movement by activating the motor neurons on its own without having input from the brain. So the spinal cord then sends nerve impulses, which we call action potentials, when a neuron is active, to trigger the muscles in your body to move so that you can retract from that painful, in this case, scalding hot plate, and do so without ever needing input from the brain. You produce spinal reflexes even without it being some type of voluntary action from the brain. It is an involuntary action designed as a defense mechanism to keep you safe when you, for example, touch something really sharp, really painful, or really hot.